I want to explain you top AI algorithms. So in a very simple language, so anyone can understand it, whether it is a technical, non-technical, whether you have a math background or without even a math background, you can simply understand this AI algorithm. So here I listed down various important AI algorithms like linear regressions, logistic, decision trees, random forest, gradient boosting. Within gradient, we have types of gradient boosting, and again learning from reinforcement learning, RNNs, all these concepts. So with a simple breakdown, so let me just open this decision tree. So in order to understand decision tree, I just divided that into a very simple definition so anyone can understand, and then images, how exactly to understand that definition, and then the mathematical equations used to understand decision tree. So I'm not going deep into the math, so it may be a bit confusing for you right now, but simply just I placed what equations are there internally so that you're going to feel more easy when you're going for an interview or while you're learning this machine learning or deep learning or Gen AI, this is going to help you. So now without wasting our time, let's get into our topic. So now whenever we are getting into machine learning or whenever we are preparing for AI or any of this, so people start saying, hey, machine learning is a lot of math, right? I totally agree. There is a lot of math. So, but the no one means like people who are working in an IT company, no one started learning this machine learning. So means like on the very first go, no one is a pro. So everyone started learning machine learning and everyone felt it's difficult, but there is a way. So you can learn it step by step so that you can be a pro. So now you are a non-mathematical background guy. You are not eligible for machine learning. There is no such rule, right? So again, you are a non-programmer. You cannot be an AI engineer. There is no such rule. So now every skill can be mastered over a period of time, just step by step kind of effort you need to give it. Now let's start with linear regression. So what exactly this linear regression is saying, let's see the definition. So imagine, for example, let's try to learn. Linear regression is widely used. So whenever you are learning machine learning or data science, the very first algorithm they teach is a linear regression. What is a linear regression? The name itself is saying linear. So now there are two different types of algorithms in your entire AI. So one, we are calling it as regression models. One, we call it as regression. Another one, we call it as classification. So one, we are able to call it as a regression, and another one, we are able to call it as a classification. What exactly meant by this regression is, so if you are trying to predict, if you are machine learning, we all know it's all about making an estimation about the future. If you are trying to predict about anything like, hey, what is your salary? So salary going to range, like my salary is 50,000, or my salary can be 65,000, or my salary can be 69,959.59, something. So now you are able to explain your data. So what is your salary? What going to be your EMI? All these numbers are continuous data. So which are having, so like this kind of numerical values, which is ranging from minus infinite to plus infinite. So we call them as what? Regression models. So if you are trying to make a statement about this kind of numbers, we call them as regression models. And what is a linear regression? So now here, imagine you have a lot of points on a graph and you want to draw a straight line that goes through the many of them as possible. This line helps you to predict where new points will be. So in a very simple way, let us just take this example where this is my experience and this is my salary. So as my salary increases or as my experience increases, there is an increase in your salary. So now what exactly there? Imagine you have a lot of points. Yes, I have a lot of points on a graph and you want to draw a straight line. Yes. So what I'm doing, I'm trying to draw a straight line. So what exactly this straight line is doing? So goes through as many points as possible. So the straight line is going as many points as possible so that this line helps you to predict where the new points will be. So in the future, if anyone is trying to ask you, man, for this years of experience, what is his respective salary? So this, whatever the line you have it, based on this line, it is going to the future. So whatever the line we have it is not only for this present, but it is going even to the future. If you know this equation of the line, what is equation of the line? Y equal to mx plus c. if you are able to know this equation of the line, what you can do, you are able to make a statement or you can make a prediction about where new points will be. So if anyone is coming with, hey, I'm having 15 years of experience, what going to be my salary? By using this line, you are able to make that statement, which is called as what? Linear regression. So the name itself is saying, so if you want to make a statement about salary, if you want to make a statement about maybe how much loan you are able to get it, for this kind of thing, we need to go with a regression algorithm from machine learning. And when your data is having a linear pattern, when your data is having a linear pattern, you need to go to a linear regression. Kant, I don't have a linear pattern in my particular data. Can I go with linear regression? The answer is no. When there is no linear pattern, you are unable to go with linear regression. So how someone can check whether the data is linear or non-linear? We have a technique, right, which is called EDA. So by using EDA, exploratory data analysis, the moment you collected the data, what you do, you start analyzing it. So now by analyzing correlation, by checking correlation, we are able to see if the correlation value is very high, whether it is a positive correlation or a negative correlation, we can say there is a linearity. If there is a linearity, if the data is means this kind of continuous data, you can build linear regression model. So in order to build a linear regression model, you need to identify the equation of the line which is passing through the data points, which is y equal to mx plus c. So to identify m value and the c value, you got this particular equation. So m value equation and a c value equation. So we call it as OLS, ordinary least square. So these are the two equations we have to identify m and c. Apart from it, if you are using straight line technique, there is one m value, one equation for m and one equation for c. If you are using gradient descent, there is another kind of equation like w naught minus alpha into dou e by dou w is the equation if you are trying to use it with the gradient descent optimization. So in a very simple way, what is a linear regression? So now if there are many points and you are drawing a straight line which is passing through as many points as possible, and you are trying to identify this equation of a line so that you can estimate the future data points. So in simple, this is about linear regression. I hope you are able to understand it. Now, let's try to understand another one, which is called logistic regression. So you can feel confused. So now, hey, like a linear regression is all about, let us use a bit light colors. Yep. So yellow and perfect. All right, we got it. Now let's use logistic. So now you can see, hey, like as you said, regression is about when you are having a continuous data, we have a regression. Then you're able to see logistic regression. Is it about continuous data? Not really. So now here, as I said, you got regression algorithms. I'm writing REG, and you got classification algorithms. So what is a classification algorithms? If I ask a question, what is your sugar levels? So, or your diabetic level, if I'm trying to check it. So you'll be getting 120 mg by dl or 140 or 150, 160. So they are in the numbers. So it is 120 or 140. This kind of numbers if you are getting, we can say regression. Now, if I'm trying to make a statement, whether you have a diabetic or not, means like if you are a diabetic, we can say yes. In case if there is no diabetic, we need to say no. Now the statement is not about how much sugar levels you have it. It is about whether you are having a sugar or you don't have a sugar. Means whether you are a diabetic or a non-diabetic, we want to make a statement. So for that reason, initially we got regression algorithms. What is the equation of regression? Y equal to mx plus c. Now this regression going to give me the values like this. So the sugar levels it going to say, but it don't say whether you have a sugar or not. Now what this people done, they have taken this linear regression, which is used for making this kind of statements, and they transformed it to perform this kind of classification. What is that? Imagine sorting candies into two jars. For example, you have two different jars and I gave you mixed candies. So you are trying to segregate them, or you are trying to, you want to eat them and you want to say whether a candy is yummy or whether a candy is yuck. So now based on that, how they look. So now you are trying to segregate them. In a similar way, Now, based on this particular numbers, based on the sugar levels, you want to say whether a person is a diabetic or whether a person is a non-diabetic. In order to make the statement, what we are doing, we are taking this linear regression equation and we are making a small transformation. So what we are doing, we are predicting the probability P that a person is trying to be diabetic. So now here, what is the probability? We are trying to predict a probability, a candy is a me. In the similar way, I'm trying to take this data, I'm trying to convert that into a probability value. So I can say whether a person is diabetic or whether a person is a non-diabetic. I'm able to understand with the help of this probability equation. So now we got a probability equation in logistic, P equal to 1 by 1 minus e to the power of mx plus c. So we call this 1 by 1 plus e to the power of e is called a sigmoid equation, 1 by 1 plus e to the power of x. So we are able to call it as what? Your sigmoid equation. What does sigmoid equation do? In linear regression, going to have a straight line. So when you are taking this linear regression y equal to mx plus c, and when you pass it into the sigmoid equation, we are able to get a sigmoid curve like this where the data ranges between 0 to 1. So this ranges between 0 to 1. This ranges between minus infinite to plus infinite. I'm not going so deep. So take it in a very simple way. What logistic is used in order to segregate two things. So if you want to segregate two things, we are using logistic. Why still logistic is called as regression? Why not classification? Is we are taking a linear regression and we are making a simple transformation. So we are able to make a classification. Take that simple theory. So in this way, we are able to perform what? Logistic regression. So that is our next algorithm. So after our logistic, we got another one, another classification algorithm. So this is also a classification. So which we are able to call it as what? Decision trees. What is this decision tree algorithm is doing? In simple, see this, like you have the theory. Yep. So now here, if you are able to see, think a tree where each branch asks a question. Okay. So think of this one. So these are your branches. So each branch is asking a question. So depending on the answer, you move to another branch. So based on the answer, either you move to another branch or you are at a leaf. So now what exactly we are doing? So now each branch is asking a question. So now see this example. So this you can take a branch. So now each branch asks a question. So like what exactly the question is? Salary at least $50,000. If the answer is yes, so now based on the answer, you are moving to another branch. Again, you are moving to another branch. Commute more than 1 hour. For example, if the answer is yes, you decline the offer. If the commute is more than 1 hour, the answer is no. Again, you got another branch. Offer free coffee. If the offers free coffee, then again, answer is yes. Then you accept the offer. If he's not offering it, so you are trying to decline it. So now think of a tree where each branch is asking a question, and depending on the answer, so now yes or no, whether the answer is true or false, based on that, you move to another branch. Either you are moving to another branch or you are trying to get a leave. So we are calling it as what? Decision tree. So in order to build this decision tree, how your decision tree know whether the answer is right or whether the answer is wrong, whether we need to go to another branch or we need to get a leave. So how someone going to decide is based on this particular mathematical equation. So whether this particular, when we ask a question in a branch, whether it need to go to the another branch or whether we need to go to the leaf is decided by entropy, decided by Gini index, and how to decide the right branch. So now which branch I need to start asking the questions first is identified by information gain and Gini gain. So these are the equations we use in your decision tree. But decision tree is having a problem. What is that problem? So if you are trying to feed a lot of data inside a decision tree, it is unable to. So now whatever the logical tree it is building, it finds difficulty to build it. So we call that mechanism. So after building certain amount of logical trees, asking questions at the branch, getting another branch or a leaf, while doing lot of stuff, it feels lost. So it is unable to do lot of questions anymore. So it feels like it lost. So like then what exactly we do? We call that approach as, if your decision tree is feeling lost, we call it as overfitting. What is that? So we call it as overfitting problem. So how can someone reduce an overfitting problem? Yes. So we are able to reduce an overfitting problem. So with the help of another two algorithms which we have it. So we call them as random forest. This is the one. So we call it as random forest. What is a random forest? So random forest is, imagine a forest of decision tree, each giving a vote and then majority vote wins in a very simple way. So decision tree contains only one tree for your entire data set. Now you are taking a data and you're breaking down the data into multiple parts. You're breaking down the data into multiple parts. So for each part of the data, you're building one decision tree. And if anyone is asking a question, instead of using one tree, you're passing the data into multiple trees. Based on that multiple trees, you get a majority voting. Based on the majority voting, you are trying to make a final statement. So we call it as what? Your random forest. So random forest decision tree falls into a category of what? Classification. So random forest algorithm helps us to perform or to reduce overfitting problem. We are able to reduce overfitting problem with the help of what? Random forest. So now this is what your random forest algorithm is. After random forest, so we got another algorithm which is called as gradient boosting algorithm. So within gradient boosting, we have types, but what is gradient boosting? So imagine again, gradient boosting is used when you are having underfitting problem. So overfitting is your decision tree can learn, it is able to identify the logics or the patterns, but it is unable to, what exactly we can do whenever we are passing new data, it is unable to work better on a new data, overfitting. Then what is underfitting? It is unable to build even the logical patterns. It is failing to build a logical patterns. Then what we do, imagine, so when your team person is not doing well, let's say take an example like decision tree is unable to do well. So then what we are doing, we imagine you have a team of artists and each artist tries to improve the painting a little bit based on the mistakes of the previous artist. For example, I am an artist, so I want to sell my painting, but I cannot draw a wonderful or a perfect painting. So I thought of, I want to collect group of painters. So first, I have just started with first painting. This is my first painting, and I just released it. So another painter came, this guy, he just saw my painting and he gave a review, hey man, this painting is not good, and he corrected that painting. So after this guy corrected the painting, again the painting which is made by me and another person, it is again corrected by another person. And again after this, my painting is initially corrected by 3 people. Now another person is correcting it. And finally, like overall 4 painters corrected this particular painting to make it perfect or to make it beautiful or to make it outstanding. So we can call together, they create a masterpiece. So that's what happening. Initially, when I have created a painting on my own, so what happened? I just have only huge amount of error. There is a lot of mistakes in my painting. So when another person added, the mistakes are reduced. Again, when another person corrected, again the mistakes are reduced. Again, when another person corrected, most of my mistakes are corrected. So now what we are doing, every time the painting is repeated, we call it as what? Iterations. So as the iterations are increasing, what is happening? The error or the mistakes in your painting are reducing. So got it? I think this is what we are calling it as what? Gradient boosting algorithm. So now this gradient boosting algorithm is, there are types in gradient boosting. So here we go. These are the different types. The very first type we got is XGBoost. So what is an XGBoost? A super fast. So now this is a basic team of painters fixing master mistakes step by step. So what exactly your gradient boosting is doing? It is a regular speed, normal speed happening. So XGBoost is a super fast and smart team of painters with the tricks to paint better. So now instead of hiring, so the regular painters, I hire the smart team of painters who are very good at the fast and they are having a lot of tricks and they can paint better. That is what we are calling it as what? XGBoost. And after that, we got another one, which we are calling it as a light boost. So light boost or light GBM, agile painters who quickly fix important areas. So what exactly? So this is fast and this is agile. So now light gradient boosting is, they are able to quickly fix important areas. It's not going and fixing everything. It is fixing the important elements of your, we can say algorithm so that it can learn better. We call it as light gradient boosting. And next we got cat boost. So what is this cat boost algorithm is doing? Painters who are experts So in handling special type of paints like classification, so this light boost, gradient boost, and regular gradient boosting algorithm, they can do both regression, they can do work on continuous data, and they can do classification. Whereas cat boost is especially trained specially on your categorical data or for your classification kind of operations, or for a categorical data, we can use this cat boost algorithm. So I hope you got a clear understanding about what is this gradient boosting and how it is working. In case if you like this algorithms, if you want to have more algorithms like this, if you want a part 2 for this particular video, you can comment part 2 in the comment section below. I may make videos on top of it. Thank you so much.